Hi, everybody. In this video, we're going to focus on inequalities. So before we do that, let's just look at some notation for how you can write your solution sets for inequalities. We have interval notation here, set builder notation, also called just set notation, and graphing. So I think probably most people have seen set notation, maybe not this as formalized as this, but you've worked with inequalities before. And the new thing for maybe most people is interval notation. So a couple things you want to note with interval notation is that it's just another way to write a set. We always write numbers from smallest to larger. So basically we're giving a range of values, saying that we're starting at A and we're going up to B, just like we see here, where X would be between A and B. We do use parentheses when the endpoints are not included. So that's when you have a less than or a greater than. And we use brackets when the endpoints are included. So that's a less than or equal to or a greater than or equal to. And you'll see that here. So notice how parentheses are being used when you have less than symbols, whereas brackets are being used when you have that equality possibility. And you can even have your interval notation have a parenthesis on one side and a bracket on the other, like they do here. Another thing I will note is that when you have positive or negative infinity, those always get parentheses as well. And infinity would just mean that it goes off in the positive direction forever, whereas negative infinity would mean that you're going in the negative direction forever. So you're going through all those negative values there. The reason we use parentheses for infinity, because if you think about it, you never reach infinity. So you can kind of never get to the end of it. So the end point can't be included there. So that's why we use parentheses. If every single number is part of your set, this is the notation we use. And this basically means all real numbers. Okay. And you can also write it like this. This is the symbol for the real number system, or like this. And on a number line here, it would be the entire graph shading. So meaning like everything would be a solution or something like that. So here you have your intervals listed in interval notation, right? So they're in interval notation here, and we're going to transfer them to set builder notation and graphing. Just really getting used to three notations here. And I'm just going to stick with X for our variable. So here, what this says is that we're starting at -1 and we're going up to 4. So our X values are between -1 and 4. Now, because I have a bracket here, I'm going to have an equality. And because there's a parenthesis, I will have no equality. Okay, so remember that parentheses get used for these symbols and brackets get used for these symbols. Okay. On a graph, so let's see, -1, -2, 0, 1, 2, 3, 4. You're shading in between those two values. And then you're going to match the interval notation. So this side would have a parenthesis and this side would have a bracket. So that's telling us that the 4 is included in the solution set, but -1 is not. We're strictly greater than -1. Here we're between 2.5 and 4. And notice that there's brackets on both sides. So we're going with the equality symbol. Okay. So this is 2.5. Let me make that decimal point a little bit clearer there. So we're going from 2.5 to 4. I'm going at 2.5. And then both of these have equalities. I can see the brackets there, so I'm just going to mirror that notation. Now here, this one's a little bit different. It says that we're starting at -4, but we're going all the way to positive infinity. So basically any value bigger than -4 counts. So we can write this as X is greater than -4. So I'm going to start at -4 here. And then we're shading in all the values that are bigger. And that's going to continue. So I'm going to put a little arrow there to show that that continues. And then notice that I have a parenthesis here. So I will use a parenthesis here. Now for my set notation, I use the more informalized version, which is probably what you're used to. If you want, you can make it a bit more formal by writing it like this. So we add squiggly brackets and we say X such that. So this is the more formalized way, but most of the time you're going to see that we'll probably just leave our answer like that without the brackets around it, or the set notation around it. Okay. Let's do a little bit more with our notation here. So we're going to talk about intersections and unions. So there is a review section about this in chapter P of your text as well. So if you need more review, you can go back to chapter P and look more about sets and unions and intersections. But I'm going to give you a quick review here. So our notation we use is this one for intersection and this one for union. So an intersection of two sets is the set that contains elements in common to both sets. So it's really where the two sets overlap. It's where they intersect. For a union, we're actually looking for elements that are in set A, B, or both. So as long as an element is in one of the sets, then we count it. So we're kind of combining those two sets together. So here are our two sets, and then we have a symbol in between. So notice here that upside down symbol, it kind of looks like an N. That is your symbol for intersection. So it helps to actually just graph and visualize where these two graphs are overlapping or intersecting. So I'm going to do it on one grid here. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 2. I'm just putting in the key values there. And I'm going to use two different colors. So I'm going to use this one in orange. So I'm going from 1 to 4. And then I'll use green for this one. So here I'm going from 2 to 8. And I'm using brackets. Okay. So we want the intersection. So we want the overlapping region. So where are they overlapping? They're basically only overlapping here between 2 and 4. So our overlapping region is going to be between 2 and 4. So I'm going from 2 to 4. I'm using just interval notation here. And the hard part is just to figure out the brackets and parentheses. So if you're intersecting, it needs to be in both. So notice that on the 2, well, the orange clearly passes through the 2, so that one's included. And then the green one has a bracket there, which means include as well. So both the orange and the green are including the 2. So this side is going to get a bracket. On the 4, though, the green is passing through the 4, so the 4 is included on the green. But notice on the orange, you have a parenthesis, and parenthesis means that endpoint is not included. So because it's not in both sets, I cannot include it in my intersection. So it's between 2 and 4, but 2 is included and 4 is not. Now we're going to do the same thing, but with the union. So here, this is a union. So basically you want to think about putting it all together, just kind of combining everything. So all the shaded stuff together is how you can consider it. So as long as it's in one of the sets, then it's fine. And it's the same set, so I'm not going to regraph this. Let's just use the same graph. So basically anything that's shaded, I want to include in my answer. So my shading comes down to the 1 and up to the 8. Okay, so it doesn't matter which color it is, as long as it's shaded. Union is like put it all together, united. Okay, so I'm going from 1 to 8 here, and then you're just going to mirror the brackets that are included. So the 1 has a parenthesis and the 8 has a bracket. Let's do one more here. All right, so I'm going down from -5, so -6, -5, 4, 3, 2, 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and there's 10. All right, so just trying to get enough of my numbers in there. I'm going to do this one in orange. So I'm going from 1 to 9 with parentheses. I'm going to do this one in green. So I'm going from -5 with a bracket, and I'm going all the way to positive infinity. So this is going to keep going this way. All right, now this first one here, that is a symbol for intersection. So you're looking for the overlapping area. So where these overlap. So if I look, because the green includes so much, it actually overlaps the entire region for the orange. So everything in here is overlapping from 1 to 9. And then just remember, it has to be in both sections. So the green is included, but because the orange has parentheses on the ends, those endpoints are not part of the orange section. So we're going to use the parentheses here. In this case, we have a union. So basically think of it as put it all together. So anything shaded counts. So the orange is already included in all of the green. So I'm just looking for everything that's shaded in. And actually the green covers the most of it, right? It covers everything. So our union here would actually be from -5 all the way through infinity. Okay, so your intersection is your overlapping region, and your union is basically unite it all, put it all together. Anything shaded in is part of that set. And I really think it does help to graph those pictures. Sometimes doing this in your head is quite difficult to visualize that. So graphing them really helps to do that. So take those extra seconds, graph, use different colors. I like highlighters here too, because if you're highlighting, let's say you have a pink highlighter and a yellow highlighter, when you highlight over each other, the orange just comes right out. So you can see that overlapping region really clearly. Same thing if you have like a yellow and a blue, if you overlap, the green will show really clearly. So it kind of makes it easy to find your intersections. Just a little tip.